Recording. Turn off. All right. What's up, folks? Welcome back. I was playing some Michael Jackson and talking to Ryan in the background. So this session, and I had a brainstorm last night, you know, pinging some of my mentors this morning that taught me a lot of network fundamentals and just IT fundamentals. And we're going to switch up how we do these lessons moving forward again. Sorry, but I think it's going to benefit you guys. So I'm going to discuss a topic, right? I'm going to discuss a topic, go in depth about it. And what'll happen is, right, we're going to jump, we're going to go back and forth between the lab, right? So it can make sense. Because if I just talk to you, right, throughout the entire session, you're going to be like, hey, you know what? I'm falling asleep. Let me get up and move, right? And I don't want you guys to do that, okay? So that's what we're going to do, right? So this is going to be a long session today. We got a lot of things to cover. And I'm doing this on purpose because come tomorrow, we can have a full lab day and have a little bit of fun. So it'll be short tomorrow, but we have to cover some things today, okay? So we are back. We are back. And of course, the chapter that we are discussing analyzing Ethernet LAN switching, right? So talking about the OSI model or the TCP/IP networking stack that is, of course, installed on most PCs today. That is layer 2, if it has to do with switching, frames, via MAC addresses, et cetera, okay? So we're going to talk about everything layer 2 within this chapter. Okay, and probably the next few chapters. Okay, so we left off, we went over the basics of how a switch learns MAC addresses, right? How things are forwarded, the 3 main functions of a switch. We went over that lab yesterday, right? Couple more things that we need to go into, right? There were a couple of things as far as the lab that we created with Fred, Wilma, Barney, and Betty, the Flintstones OGs, and how we showed about dynamic learning from the switch. And so we're going to go a little bit more in depth, and I'm going to explain a few things. We're going to jump back and forth into the lab, right? So everything can make sense, okay? So if you read the top of the title of this slide, right? Flooding unknown unicast broadcast frames, right? So we spoke about, right? Let's go here. We spoke about this, right? We spoke about forwarding known unicast frames, okay? And so the switch knows, hey, if Fred wants to say good morning, Wilma, right, or send a message to Wilma, right, the switch is going to know where to send it to, right? That is forwarding a known unicast frame, okay? But what happens, right? What happens when a switch doesn't know where to send that frame, right? And so, right, I'm going to talk through it a little bit, right? And so let's say, right, if we go to our lab, let me go ahead and pull that up. If we go to our lab, okay, we have .50, .51, .54, and .53 on the, right, on the 192.168.1.0/24 network, right? What happens, right? What happens to that frame from a layer 2 standpoint? We'll talk about what happens at the layer 3 standpoint, but what happens at the layer 2 standpoint if the switch doesn't know where to send it? Okay, let's test it out, right? Let's pull up Fred, okay? So I pulled up Fred, right? Okay, and so let's try to ping an IP that doesn't exist, right? And before we even, that doesn't exist in this network. And let's do 55, right? And before we do that, right, let's go ahead and make sure we make it continuous by putting a -T. Let's do, right, let's do some packet captures, okay? Let's see what's happening. And again, going over one of the 3 main functions of the switch, just to review, is that, of course, it is going to forward the frames out of all interfaces except for the interface that it received the frame on, right? Okay, so if Fred sent it trying to reach, .55, right, it's going to forward it out of all frames, right? But how does that look on the wire? Okay, so you guys can see it, right? Let's go ahead and go to the packet capture, and let's go ahead and ping in real time, right? And a host that doesn't exist on this network. Okay. All right. So let's go ahead and go to the packet capture. Right. So we're not going to talk about layer 3, right? We're going to talk about layer 2. Okay. So let's talk about what we did again, right? And let me go ahead and stop the capture, right? And so Fred is trying to reach dot 55, right? Let's call that Dino, right? And he doesn't exist. Dino doesn't exist on this network, right? He's not connected to this switch, or he's on this broadcast domain. So whenever, right, a switch receives a frame and it is trying to, it doesn't exist on the MAC address table, but it's trying to reach it, it is going to go ahead and send a broadcast frame, right? It's going to send a broadcast to see who responds to this frame that I sent, right? This packet that I sent that's encapsulated within this frame. Okay. And so if we go to layer 3 now, right? If we go to layer 3, right? I'm sending it and I'm saying, hey, who is dot 55? That's from a layer 3 standpoint. Okay. And I'm just talking about ARP. ARP is a layer 2.5 protocol, right? It works between 2 layers, layer 3 and layer 2, right? And this is just an example. There's many other types of broadcasts, but let's stay here for now, right? So Fred is trying to find, Fred being dot 50, he's trying to find Dino dot 55. He sends it on the wire, right? Since that ARP, right? And from a layer 3 standpoint, right, it's going to go ahead and send it, right, on the network. But from layer 2, it's going to send it to all Fs, right? The destination, all Fs, is going to send it everywhere except for the interface that it received the frame on, right? To see who's going to respond to it, right? And remember, that's what happened yesterday, okay? That's what happened yesterday whenever Fred was trying to reach out to Barney, okay? We saw the MAC address table. The switch did not learn about Barney just yet, okay? Didn't learn about Barney just yet. So it's going to go ahead and send, hey, Barney, where are you? Right? It's going to send that broadcast frame, right? To go ahead and see where it lives, right? And the technical term for that, right, is because again, essentially it is a frame whose destination address, right, MAC address is unknown to the switch. It is called an unknown unicast frame. Okay. Or you can just call it unknown unicast. Okay, but unknown unicast frame, from a layer 2 standpoint, that's exactly what it's called, right? And how it looks like from a layer 2 standpoint, it's going to be all Fs, right? When it's an unknown unicast frame, it's going to be all Fs, right? And that is the broadcast address. Whenever anything from a layer 2 standpoint wants to send a broadcast message, it is going to be all Fs. Okay. All right. And just a quick thing here, right? The reason why I say it's layer 2.5, right? You see layer 1 right here, and layer 2 right here. This is not essentially layer 3, right? This is why I said layer 2.5. It has some info, right, as far as layer 2 and layer 3, but it doesn't actually have a source and IP address, right? Section where it says layer 3, where am I sending it to, and where is it coming from? Okay, so that's a little tidbit about ARP, but let's keep going because again, we have a long session. Let's go back to the PowerPoint. There we go. Okay, so that was flooding unknown unicast frames, right? And talking about broadcast frames, right? Broadcast frames, all Fs. Unknown unicast frames are a type of broadcast frames, right? And of course, how the switch's behavior on that is going to send that frame to all Fs, right? Send it to all ports except for the one that it received the frame on, right? In hopes to go ahead and get a response. Okay, so let's keep going, right? Let's go ahead and talk about one of my favorite topics here, right? Is spanning tree. There is going to be a whole chapter on this, and we're probably going to break this up in probably 2 or 3 weeks, right? But we are going to go ahead and just talk about this tidbit, right? So, right, the feature spanning tree, or STP, right? And so its purpose, right, is to prevent loops within a network, right? Short and sweet from a layer two standpoint. Okay. So without spanning tree, right? If Bob tried to send, Bob tried to go ahead and send something to Archie, right? Well, I'm sorry. Let's talk about the diagram. If Larry tries to send something to Archie, right? And all three of these switches, right? All three of these switches have no spanning tree running. It's just going to go ahead and keep sending it in a circle, in a circle, in a circle, right? To the point to where they're replicating these frames at milliseconds, to the point to where the switches become unreachable and the network comes down, right? AKA a broadcast storm. Okay. So back in the day, they had to go ahead and fix this, right? So they said, all right, let's go ahead and do spanning tree, right? So if we have a redundant topology like this, what do I mean by redundant, right? So if the switch that Bob's is connected to, right, is down, right? And or I'm sorry, if Bob wants to reach Archie, right? But Archie's down and Archie may be connected to a different switch, right? He can go ahead and plug into Larry's switch, right? And still be reached, right? This is just an example, but this is what spanning tree does, right? It provides provides loop free, it does loop free prevention, right? But it also, right? It also makes sure there's only one way, one flow of traffic throughout the network, right? How does it do that? It blocks some ports on certain switches. It does negotiations, right? As far as saying, hey, who's the root switch? And we'll talk about that in a further chapter, right? Who's the designated switch and who's the non-designated switch within a triangle, in a sense, right? Because every spanning tree setup is typically a triangle, okay? But we will talk about that at a later time. Okay. So just want you to, I want you guys to go ahead and take a look at what spanning tree is, what happens if spanning tree does not exist, right? The frame loops forever, right? And of course, in chapter 9, right, we'll go ahead and touch on the spanning tree protocol concepts, which of course will go in depth about how spanning tree works. Okay. Let's continue on with this layer two overview. Okay. All right. So right? So there's a few things, right, out of the box, right, as far as Cisco is concerned, right? And many vendors copy Cisco, right, and mimic Cisco, right? These boxes, right, these switches come right out of the box, right, with these 5 settings, okay? Because again, it's a switch, right? It has to be plug and play, right? The interfaces are enabled by default, ready to start working once a cable is connected, right? Meaning if Ryan, right, he gets a switch, plugs it in, connects some hosts to it, automatically, if he connects maybe the router, right, to the switch, users should be able to go, or the firewall, whatever you want to call it, they should be able to, automatically out of the box without Ryan configuring the switch, start working and start reaching out to Google and going on Twitter, CNN, whatever, right? This next one is an important one. And we'll talk about VLANs in the future. All interfaces are assigned to VLAN 1, right? Or virtual local area network 1. Okay. We're going to talk about VLANs probably in the future. And we'll go in depth, make sure I go in detail. But um, that's one important thing you need to know across the board, not just Cisco, but for each vendor. Okay. 10 by 100 and 10 by 100 by 1,000 interfaces use auto negotiation by default, right? What does that mean, right? 10 megabit per second, 100 megabit per second, and 10 megabit per second, 100 megabit per second, and 1,000 megabit per second interfaces that are on switches, right? Auto negotiate the speed by default, right? If Ryan plugs in maybe a PC, right? On it, it's configured, 1,000 megabits per second on internet, right? He plugs into the switch. They're going to go ahead and send frames to each other, right? And send messages to each other and say, hey, what speed are you running? Hey, what speed are you running? Perfect, right? But again, that feature of auto negotiation is set by default. That's how it's able to communicate with whatever's plugged in to that switch port and negotiate, right? Now, of course, it is possible, of course, to configure a static speed, right? A static duplex, okay? But from a default standpoint, out of the box, these are the settings, okay? Number 4, of course, what we've been talking about, the MAC learning, forwarding, flooding logic, all works by default, okay? From a Cisco standpoint. STP is enabled by default. One of the last default settings. For Cisco, absolutely. For many other vendors, not so much. I actually had some experience touching different switches over my time. Juniper, yes, I believe that's if it's a switch, it's enabled by default. FS switches, no, you have to enable spanning tree. Extreme switches, I do not believe so. You have to enable that by default. Few other vendors, but these are the default settings out of the box, how a Cisco switch is set up. Okay, let's keep going. All right, so we're talking about these default settings, right? And so, and I know we discussed, how a switch learns about MAC addresses, learns about different hosts that are connected to it, right? But let's go ahead and dive deep into, what that looks like, right? And please ask any questions that you have, right? So demonstrating MAC learning, and we'll hop in the lab after this. To see your switch's MAC address table, right? Use the show MAC address table command, right? With no additional parameters, this command lists all known MAC addresses in the MAC table, right? Including some overhead static MAC addresses that you can ignore to see all the dynamically learned MAC addresses only, right? Instead, use the show MAC address table dynamic command, okay? That was a little bit quick, but basically what it's saying is, right? If you just do the show MAC address table command, right, it's going to show you all the MAC addresses, whether it was configured, statically configured per port by you, right, in global configuration mode, right, because that's the only way we can make changes to the device, or, right, if you just want to see what, the MAC addresses that the switch learned, we can do show MAC address dynamic, because it dynamically learned it by one of the main functions of the switch, right, and learned it by getting a frame, right, getting a frame sent to it, right, and then learning it off the source MAC address, okay? So let's demonstrate that again. Let's go ahead and hop in the lab, take a little lab break. All right, so let's go ahead and pop that, and let's go ahead and open up the switch's MAC address, right? So let's go ahead and experiment, all right? Let's go ahead and reset this terminal. There we go. All right, so show MAC address table, right? So we're using that command, right? Just to see everything within the MAC address table. We don't see anything, right? And I'll explain why, right? And so, of course, this lab was on, right? It was cut up, but, right, the MAC address table has a timer, right? What does that timer do? That timer goes ahead, right, and they call it the aging time. The switch keeps MAC addresses in the MAC address table for a certain amount of time. Why is that, right? Because if there's no communication, right, if there's no communication, we don't want to keep those entries within the MAC address table, right? Because we can cause errors as far as, syslog errors that's showing, hey, MAC flat, et cetera, right? And we have a limit of 8,000 MAC addresses that can be in a table, right? And we don't want to go ahead and, 8,000 entries, right? But with space for 7299 entries, okay? So we don't want to go over that limit, right? So let's take a look at that aging time, right? To take a detour, right? Aging time, okay? Right? So it's 5 minutes, 300 seconds, okay? So if there's no communications by host, whether it's connected or not, right? Whether it's connected or not, right? On this switch, it is going to remove it from that MAC address table, okay? But, right, all the hosts are on, right? And we have IP addresses. If I go ahead and ping a host, right? Send a ping from one host and send a ping to a host that exists here, right? Let's go ahead and do Barney, okay? Guarantee you, if we look at the MAC address table now, right, we see Barney and Fred, right? We see the interfaces that it's live off of, okay? And the switch dynamically learned this, right, based on one of its major functions, okay? All right, let's go ahead and keep going, right? So we can go ahead and take a look at this, right, and see all of this, right? But, right, let's take a look and see how, a static configuration looks, all right? So let's go ahead, right? Let's ping all the hosts so they can live, right? So they can live within that MAC address table, okay? So I'm pinging Wilma, okay? And let me ping Betty, okay? Okay, perfect. All right, so now, right? And let's go ahead and reset terminal. There we go. All right. There we go. All right. So we have all the MAC addresses, right? And so, right, but they were learned dynamically. Let's go ahead and configure a static entry. Okay. So let's go to global configuration mode, which is configure terminal. Okay. And let's see how we can go ahead and configure that, right? Because of course I'm not a machine and I wouldn't know that by heart. Let's go ahead and see. There we go. Okay. And that. There we go. All right. So if we go up to M, right? Global MAC configuration subcommands. All right, let's do MAC. Okay. Address table. Perfect. Right? Static. Right? So we're statically going to set that MAC address. Okay. So 48-bit MAC address, right? So let's go ahead and pick one. Right? Let's pick Betty. Okay. Let's pick Betty. Oops. There we go. Question mark. VLAN, right? It's asking us what VLAN. Let's put VLAN 1, right? And interface, right? And put gigabit, and she lives off of 0/3. Okay. So 0/3. Okay. So now, right? Let's go ahead and check the MAC address table, right? Just doing the default command. Okay. So Betty's in there, right? She's in there, right? So now, what happens if we clear that MAC address table, right? Again, we're still demonstrating MAC address learning and the difference between dynamic, right? And learning it dynamically and setting it statically. So if we clear the MAC address table, right? Dynamic, right? That should give you a hint. Okay. So we were only able to clear the dynamic entries. What should we see in the MAC address table now? We should only see Betty. Okay. And now you have the option to do that, right? To set static entries or what have you, right? But what's the downside of that? What happens if you do this? Go ahead and choose another port. Okay. Let's open up the switch and let's open up Fred again. There we go. Okay. So let's check the MAC address table. Okay. So it still has that static entry. Let's go ahead and try to ping Betty now. Okay. And she's at 53. Nothing's happening. You see what I mean? Right? So what we did, right? We told the switch, we did one of its major functions for it. We told them what the destination MAC address was for a certain host, right? Gigabit 0/3. If we statically set it, if we move Betty to another port, we have to change that configuration as well. Because if we don't, the switch is not going to know where to send it, right? It's going to say, oh, well, hey, Betty lives off of 0/3. she's connected off currently gigabit 1/0. Sorry, dude, you're gonna have failures, right? So that's an example. That's how that works. Okay, so let's go ahead and fix that. All right, all right, there we go. All right, okay, Betty's fixed. And if I pull up the switch, I try to ping her now. Betty's working. Betty's all good, right? Okay, so that's the difference between static and dynamic and the bits and pieces that come with it, okay? Quick note, right? Let's go ahead and pull up the MAC address table again. Of course, you see this VLAN part. We're going to talk about VLANs in chapter 8, right? I believe the chapter is called Implementing Ethernet Virtual Local Area Networks, right? Or Implementing Ethernet VLANs. We're going to talk about that at chapter 8, and that's right before the spanning tree chapter, okay? So let's go ahead and go back to the PowerPoint. Let's move on, right? Since we went ahead and touched that, okay? Went over, looking at this. Let's go ahead and talk about this key thing, right? And it can help you guys as regards to verification, troubleshooting, et cetera, right? With every switch, every device, there is a way to look at all the interface and look at the status of them as well, okay? So, right, if we do a show interface status, right, if we look at this screenshot, it'll show us the port, the status being, letting us know if something is connected or something is not connected. Basically telling us, right? But, reading between the lines. This status column, it is telling us layer 1. Is something connected or something is not, right? Along with of course, right? Along with the speed column and the type column, right? Those are all layer 1, okay? All right, and we can put duplex in there as well. Layer 2, right, is that VLAN section, all right? We can also verify what VLAN that port is sitting off of. Let's say, right, Ryan configured multiple virtual local area networks or multiple VLANs, right? And he's plugged, right, Betty into one port that maybe is on VLAN 100, but Fred, Wilma, and Barney on VLAN 1, but you're trying to ping Betty and it's not working. You can do this command and see, I have a layer 2 issue. Layer 1's fine. I have a layer 2 issue. Need to change the VLAN. Okay. But again, we will touch on VLANs later, right? Let's go ahead and take a look at that, right? All right. So everything's connected, right? Maybe the MAC address table is empty, right? Matter of fact, let's whoops. There we go. There we go. All right, let's remove that. Remove that static entry. There we go. All right, so now if we check, there we go. All right, so let's clear. All right, so we cleared it, right? What's going to happen if we put in show interface status? All right, right? The same thing, right? Even though the MAC address table is empty, okay? We wiped out the MAC address table. It's still going to show us layer 1 and layer 2 here, right? We have things plugged up in the first 4 interfaces, right? Right, layer 1, it's connected, right? Right? The duplex, right? Auto negotiation, right? When you see A, that means the duplex was auto negotiated. And of course, if you see speed and you see auto under it, it means auto negotiation happened there as well, right? And of course, it's also able, from a Cisco standpoint, also able to tell you what type of cable it is. RJ45, maybe it'll tell you if it's fiber, et cetera, et cetera. And of course, from a layer 2 standpoint, you can see the VLAN. Okay? All right. So there's that, right? But there's another command you can use to actually see specific the statuses of a interface, right? So we see show interface status, right? But let's be specific and go to the actual interface, right? So let's go to gigabit 0/0, right? In depth, right? We see this here, gigabit 0/0. It tells us like a brief what everything looks like, right? But if we do a gigabit interface, that exact interface, right, it's telling us, right, layer 1 is up, right? Layer 2 is verified, meaning the line protocol. We'll talk about that in the future. That's up. So layer 1 and layer 2 is up. Okay, it's connected, right? It tells us some more information, right? The MAC address of that NIC of that interface, right? On the switch, right? The MTU, auto duplex, right? Couple of other things, right? Couple of other fun stuff that we'll talk about in the future. But this, this can also help you within a troubleshooting standpoint and verification standpoint, if you're ever getting to the switch. And these are a couple of things you will need to know for the exam, right? And we're going to jump into analyzing, we're going to jump into this in chapter 7, right? As far as when it's talking about configuring and verifying switch interfaces, right? And the actual section is called analyzing switch interface status and statistics, right? So we'll jump into that later, right? So, of course, you see some stats. The last command I'm going to show you, right, for switch interfaces and of course configuration statistics and checking stuff is, all right, we put in the interface, right? But we can see, right? We can see, and of course you didn't see it here, but we can see actual, how many packets went in, how many packets went out, the type of packets that went in and out, maybe unicast, maybe multicast, maybe broadcast, right? We can see the amount of it set. And let's try to generate that. Let me take a look, all right? So, okay, so we're generating that. Okay, so nothing popped yet, so something probably wrong with that. But again, that command, and I'll get you guys a screenshot later, is how you can take a look at the counters to see if anything is traversing that port. Okay, so finding entries in the MAC address table, right? I know we've talked about the MAC address table probably 10,000 times, right? But there's this section is going a little bit more in depth, which is good to show you how you can specifically take a look at, take a look at the MAC address table and find what you're looking for. Okay, so this command, show MAC address table dynamic, right? We talked about what that's going to do. It's going to show us all of the dynamically learned MAC addresses on that switch, right? But we can also add, right? We can also add a few, a few keywords to go ahead and a value, right, to go with it, right? So we can add in for this command, we can add in the address and of course the address, right? The 48-bit hex address alongside of that. And we can see the exact location, the exact port that it lives off of. How does this help you, right? Of course, if we look at my lab, right, we see we're connected. We got 4 hosts connected to a switch. Imagine if you have a 48 port switch, okay, and you have 48 hosts hooked up to all of them, right? It'll be painful to go ahead and take a look at, and try to search. If you put this in, it drills down and makes you see what port is connected to, then boom, you can go ahead and continue on your search to see where a host live, et cetera, et cetera. Okay. Now, right, they also have this show command, right, for the MAC address table, searching by the interface, right? Maybe, Ryan knows that something is connected to gigabit 0/1, but he doesn't know the MAC address. He's going to say, you know what? Cool. I'm having issues with 0/1. Let me type in show MAC address table dynamic interface, right? Faster than 0/1. Here it is, right? So this is another way you can go ahead and drill down and see what the actual, if you're trying to look for a specific host, et cetera, et cetera. Okay. Whoops. And last but not least, of course, we're going to talk about VLANs in the future, but you can actually search by VLANs, right? By putting, VLAN and of course the VLAN number at the end of the show MAC address table dynamic command. Okay. So there's that. Okay. And of course, there's a static alternative as well, right? But we'll go over that in the future. I don't think it'll add value of going over that now. Okay. Last but not least, okay, we have managing the MAC address table aging and clearing. We spoke about the aging time, right? right? And of course, as you guys can see at the bottom, right, the total MAC address space available. And look, and I'm glad I corrected myself. The total MAC addresses it can have is 7,299, right? In that MAC address table, right? And it varies by platform, right? Maybe a 9,300, right? And a 9K can have much, much more, right? So it varies. That's not static. What is static, right? By default, coming out of the box, is that global aging time, 5 minutes. Okay. And remember, if there's no communication from a host in that 5 minutes, the MAC address table is going to say, hey, wipe my hands clean. I'm going to remove it from the MAC address table. Okay. So last but not least, right? Let's say, right, we have the MAC address table, but we want to go ahead and just wipe the MAC address table out, and for whatever reason, as far as it has to do with troubleshooting, et cetera, right? You can go ahead and remove it by VLAN, by interface, or by MAC address, right? So of course, you can see that those commands below. So by VLAN, clear MAC address table, dynamic VLAN, etc., right? Or by interface, clear MAC address table, dynamic interface, boom, right? And of course, interface ID, and by MAC address, clear MAC address table, dynamic address, boom, right? So let's go ahead and do that, okay? Let's go ahead and pull up the switch, right? And let's pull that up, right? So let's ping every host, and let me go ahead and pull up. There we go. All right, there we go. All right. So let's ping every host in this network from Fred, right? So we can go ahead so that MAC address table can learn about each host. Okay. 3. There we go. And 54. Okay. So if we go ahead and take a look at that MAC address table, right? We have all 4 entries, right? So let's say we want to go ahead and clear it by VLAN, right? We're going to type in clear MAC address table dynamic question mark VLAN, right? And we can put the VLAN number and be VLAN 1. Boom, right? And so if we look at the MAC address table now, we have nothing there. Okay. But again, with great power, one of my favorite movies, Spider-Man, with great power comes great responsibility. You have to understand what the command does and what you're doing. Okay. If you say, hey, I'm troubleshooting VLAN 1, right? And I can't just get this one host to get off this port. Let me go ahead and just clear the MAC address table of the entire VLAN, right? What can happen is for a short amount of time, you can go ahead and stop traffic flow, right? For a short amount of time, but again, that can be critical if maybe a server at one location is trying to transfer files to another location. Then boom, you caused the hiccup. Okay. So be very wary of course, what you're doing, right? Let's go ahead and generate the MAC address table again. All right. Okay. Let's go ahead and generate these entries again. Okay. Okay. So look at the MAC address table. All right, we populated it again, right? So Ryan, right? Ryan he says he sees some syslog errors, and we'll talk about syslog errors and syslog messages in the future, right? He sees a syslog message that comes across the terminal, right? The CLI, and says, gigabit 0/2 is having issues, right? Let me go ahead and just clear the MAC address table entry just for that interface, right? We can do that, right? So clear MAC address, right? Same thing. Dynamic, okay? Interface, right? And question mark it, right? Gigabit, right? And we said gigabit 0/2, right? Boom, right? So if we go to verify, right? Verifying the MAC address table, gigabit 0/2 isn't there. okay, right, which is Wilma's PC, right? So let's go ahead, and that's how you remove it, remove a MAC address table entry by interface, okay? Let's go ahead and add Wilma back. So quick tidbit while the pings are going. The great power comes great responsibility. I'm gonna say it again. When we talk about trunks, right, in connections from one switch to another switch, right? We can have two switches, right? And it maybe switch one knows about Fred and Barney because it's directly connected, but it learned about Wilma and Betty off of switch two, right? And so if we do a command that wipes it off of interface, we have to make sure we understand if it's a trunk port, right? Or if it's a access port, right? Don't worry about that terminology now. We'll get into that in the future. If we do this command with a trunk port, okay, we have the possibility of wiping out a lot more VLANs, right? So we have to make sure we know what we're doing. We're being very careful. And again, my favorite quote: "With great power comes great responsibility." So know the power that you have and know what you're doing, right? Last but not least, right? We can clear that MAC address table entry by the MAC address itself, right? So we see the MAC address table, and right, you still got the same command, right? Dynamic, right? And let's go ahead and put address, right? And it's going to ask us for the 48-bit MAC address, right? Let's go ahead and do give it 0/0/2 again. Copy, right? And let's see if it's back in the MAC address table. Boom, it's wiped out. Okay. And so that's it, right? That's typically it as far as it has to do with managing the MAC address table and aging and clearing. Okay. So that's it for today. Okay. We are still in this chapter. Take a read if you can. Practice what I just went over in Packet Tracer. You can do it. You don't need packet captures like I have in Wireshark or what have you. You don't need that. Just practice, do a couple of labs, right? And it'll all make sense. If it doesn't, you can reach out to me. Okay. Well, you guys have a great day, and I'll see you tomorrow.